In this video, we're going to be learning about quadrantals and inverses when we're working with radians, and you'll probably be pleasantly surprised that it's really similar to how we work with degrees. So our quadrantal angles, remember, are just those angles that lie on the x and y axes. So if we have our graph, this time when we have our points 1, 0, 0, 1, -1, 0, and 0, -1, we're going to be using radians to describe these points. So remember, here's 0, here's pi over 2, here's pi, here is 3 pi over 2, and here is 2 pi. So if you see any of these values, we're working with quadrantal angles. And if you remember, if we have x comma y, x is the cosine of that angle and y is the sine of that angle. And tangent is sine over cosine, which we know is y over x. So the same rules apply, but now we're going to use different names for the angles. So say we have something like cosine of pi. Well, I know pi is the point way over here on the unit circle, which is the point -1, 0. Cosine is the x value. So the x value there is -1. So cosine of pi is just -1. Let's say I have cotangent of pi over 2. So first off, I'm going to find the angle pi over 2. That's right here. I'm going to write out, that's the point 0, 1. And this is pi over 2. Now, I know tangent of pi over 2 is going to be, it says it right up here, y over x, which is 1 over 0. Now remember, if we get 1 over 0, we can't divide by 0, so this would be undefined. But luckily, I wasn't looking for tangent, I was looking for cotangent. So if I flip 1 over 0, I end up with 0 divided by 1, and 0 divided by 1 is just 0. So this is okay, I can do 0 divided by 1, so my cotangent of pi over 2 is 0. The last thing that I want to cover is inverse trig functions. So these are really similar to before, except now we're going to be working with radians instead of degrees. So inverse trig functions are asking you to find the angle measure. So a problem like this might look like sine of theta equals square root of 3 over 2, and I want to know, usually it's between 0 and 2 pi that I'm interested in all the angles. Now, when you plug these in on your calculator, they're only going to usually give you one answer. So a lot of the times with these, you're going to end up with 2 different answers. So let's say we have sine of theta is square root of 3 over 2, and I want to know where that happens. Well, if I look at my chart for what angle has some sine value of square root of 3 over 2, and I'm working with my radians chart, the reference angle for that is pi over 3. So I know at least I've got pi over 3. Now I want to know, where else am I going to get a value that's square root of 3 over 2? If I think about all students take calculus and I want the 2 positive values, I want this value and this value. So what's the value that's paired with pi over 3 that goes in the second quadrant? Well, that's going to be 2 pi over 3. So remember, I have these other 2 angles that are 4 pi over 3 and 5 pi over 3. So those angles I can't use because they would have a negative value. So the 2 angles I'm going to use are pi over 3 and 2 pi over 3. And there's my final answer. Now let's say I have another one. Let's use a different color. So let's say I have tangent of theta equals -1. The first thing I'm going to do is think, well, I don't know if -1 is going to appear on my chart, but where is there a value of tangent that's 1? That happens with a reference angle of pi over 4. Now let's look at all the angles that have a reference angle of pi over 4. So these are actually nice 45-degree angles, so we can just draw an X. So we've got pi over 4, we've got 3 pi over 4, we've got 5 pi over 4, and we've got 7 pi over 4. So which of these angles are we going to choose? Let's think. All students take calculus. I want there to be a negative value. So where is tangent negative? Well, in the all one, it's positive. For sine, it's negative. And for cosine, it's negative. So that means in the second and fourth quadrant, we have a value of -1. So my theta is 3 pi over 4 and 7 pi over 4. So you're doing the same thing that you did for degrees, except now we're going to use the radians chart.